This video will be on real numbers and the unit circle. Recall that the radian measure of an angle was defined in terms of the radius of the circle. The most important circle in trigonometry is the unit circle, which has a center at the origin and a radius of 1 unit. Thus, some important points on this circle are 1, 0, which corresponds to 0 pi or 2 pi, negative 1, 0, which corresponds to pi, 0, 1, which corresponds to pi over 2, and 0, negative 1, which corresponds to 3 pi over 2. Thus, this shows that for each x value, there are 2 y values that correspond to it, and for each y value, there are 2 x values that correspond to it. Also, recall from geometry the equation of a circle with a center of hk and a radius of r, which is x minus h squared plus y minus k squared, which equals r squared. Therefore, the equation of the unit circle is x squared plus y squared equals 1 squared, and 1 squared is just 1, so it equals 1. And this makes sense because the h and k values are both 0, since the unit circle is centered at the origin. So thus x minus 0 is just x, and y minus 0 is just y, and the radius is 1 unit. Here are a couple practice problems with that idea in mind. Here, the first question is showed at the point 1 over 4, comma, square root 15 over 4 is on the unit circle. So all you want to do is 1/4 squared, which is 1/16, plus the square root of 15 over 4 squared, which is 15 over 16. And you want this to equal 1. 1 plus 15 is 16, 16 over 16 is 1, so 1 does in fact equal 1. Therefore, this point is on the circle. For the second question, it's the point square root 5 over 3, comma, y is on the unit circle in quadrant 4. Find its y coordinate. Quadrant 4 is important because it tells us that the y coordinate has to be a negative number. So what we do is we take the square root of 5 over 3 and square it, plus y squared equals 1, which gets us 5 over 9 plus y equals 1, y squared, sorry, and then we get y squared equals 4 over 9, square root both sides, so y equals plus or minus 2/3, and thus, since this is in the fourth quadrant, y equals negative 2/3. Here we have a picture of the unit circle, and we see that there are some real numbers that appear often, like pi over 6, pi over 4, pi over 3. We have 2 pi over 3, 3 pi over 4, 5 pi over 6, and so on and so forth. And knowing the coordinates of these points are critical in solving trigonometric problems. We also see that there's a lot of symmetry in the unit circle, so we want to make sure to know the quadrant 1 special angles, 30, 45, and 60, because that will help us with the quadrant 2 special angles of 120, 135, and 150, quadrant 3 special angles, and quadrant 4 special angles. So in order to find the terminal points of the 30, 45, and 60 degree angle, we need to use trig to find the y value, this, and then the x value, which is this. So we know that sine of 30, or just sine in general, equals opposite over hypotenuse. So we know that the opposite, which would be this angle, or this side, equals the hypotenuse of 1 times sine of 30, which gets us 0.5. And the same thing with cosine, which would get us square root 3 over 2. We know that for a 45, 90 degree angle, these two sides are the same. So if we can find one side, we'll know the other. And then we know that sine of 45 degrees equals square root 2 over 2. So both of these are square root 2 over 2. And then for 60 degree angle, it's flipped with the 30 degree angle. So we know that the x would be 0.5, and then the y would be square root 3 over 2. So then we know Now for quadrant 1, the points are going to be positive in the x coordinate and positive in the y coordinate. For quadrant 2, it's going to be negative in the x and positive in the y. Quadrant 3, negative for both. And then quadrant 4 is positive in the x and negative in the y. Now let's talk about reference angle and reference numbers. So we want to let a be a real number. The reference number a prime is the shortest distance along the unit circle between the terminal point for a and the x-axis. The reference number is always equivalent to an angle in quadrant 1. Here we see that in the first quadrant, the reference angle is always just going to be the regular angle. In the second quadrant, we see that the reference angle is going to be pi minus a. We see in the third quadrant that the reference angle is going to be a minus pi. And in the fourth quadrant, the reference angle is going to be 2 pi minus a. And we see that the reference angle is always an angle that would fit with its degrees in the first quadrant. This helps us with the symmetry in the circle, because we see that an angles with reference angle of pi over 6 are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. This means that they'll all have the same points, they'll just have different signs depending on which quadrant they're in. This helps us get to the idea that all angles are related to an angle in quadrant 1. So if you can determine the reference angle, you can use the same coordinates and adjust the signs according to the quadrant. And here we have a couple practice problems with 5 pi over 6, negative pi over 6, 23 pi over 6, and negative 7 pi over 2. So for 5 pi over 6, we see that if you add a pi over 6 to that, you get pi. So you know that the reference angle is thus pi over 6. With negative pi over 6, we know that that's going in the clockwise rotation, so thus it's actually 11 pi over 6 if it's going counterclockwise. Thus it's in the fourth quadrant, meaning that we would do 2 pi minus 11 pi over 6, which would get us pi over 6, so the reference angle is pi over 6. For 23 pi over 6, that is an angle that is outside of one rotation. So we would do 23 pi over 6 minus 2 pi, which would get us 11 pi over 6. Therefore, we would do 2 pi minus 11 pi over 6 to get pi over 6. So the reference angle is pi over 6. For negative 7 pi over 2, this is outside of one full rotation in the clockwise direction. So we would add 4 pi to it. 4 pi minus 7 pi over 2 is pi over 2. Therefore, the reference angle is pi over 2. And that is all you need to know for real numbers and the unit circle.